asked this on his first exam. He gives you 10 problems to practice, and you need to answer 5 different questions that are listed on the handout. And I have all of the structures drawn. You just need to print the handout and work yourself through. I'm going to show you a few problems just so you can get an idea of how you're going to tackle this. But make sure you guys practice, because this is definitely on the exam, and it's like 25-point problem. Alright, so let's talk about testosterone. That's the first one that's going to be on your list. So the first question is circle and name on all the functional group. So you need to recognize if you know all of your functional group or not. You have alcohol, there is alkene, and there's ketone. So you need to circle them and name them. Okay, so we have 3 functional group on the first one, and that's the answer for 1. Right. Number 2 is how many carbons are chiral in this molecule. So you just have to go through it and see which one's chiral. This can't be, this one is 4 different things. This one has 4 different things. That one as well. Okay, so you just gotta go through it. Whichever carbon has 4 different things and no symmetry around it, then you have to pick that carbon as being chiral. So you have 6 chiral carbons. So that's the answer for number 2. How many carbons are there? Usually you should practice to just come up with the entire formula, because he can ask you how many carbons, how many hydrogens, anything. So it's easier if you make a habit of writing all of the atoms together. Okay, so how many carbons are there? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so I think there are 19 carbons. Always do this step twice, because we make a mistake. We sometimes don't see the carbon being there. So answer for 3 is 19. But if you want, you can go ahead and write the whole formula for your own practice. Okay, the fourth question is how many lone pairs are there? So keep in mind, oxygen is always going to have 2 lone pairs. And we don't have nitrogen in this case, but if you do have nitrogen, nitrogen's always going to have 1 lone pair. So in our case, we only have 4 lone pairs. 2 on this oxygen, 2 on the other. Okay, and how many sp2 atoms we have? This is a trick question. So whenever a lone pair containing atom is next to another sp2 system, you had to count that atom as being sp2 as well. This was different in Gen Chem, so that's why I'm stressing on it. I'm repeating again. A lone pair containing atom next to an sp2 system is always going to be sp2. Alright, so let's look up here. We have this oxygen, that carbon being sp2, that sp2, that's sp2. This is not, because it's not next to any sp2 system. So we have 4 sp2 hybridized atoms. Keep in mind the functional groups that correlate with this rule. Amide, which is a nitrogen next to a carbonyl, since this is sp2, the nitrogen becomes sp2 no matter what's attached to it, because this lone pair can donate into the system. So amide's going to be the case. ester is going to be the case. And even carboxylic acid will do the exact same thing. So in all of them, the lone pair containing atom is next to an sp2 system, so that atom becomes sp2 as well. All right, that's what you need to do for the entire handout. So keep in mind what we do. Make sure you use different color of pen, or make sure you know your markings, because sometimes it's too much in one problem, so you can't really see what you were counting. And the very last molecule on this handout is Taxol, and it's the biggest molecule. And if you can go through Taxol, anything he gives you on the exam, you will be able to do it. So that's why I said keep practicing until you know what you're doing, so you save time on the exam and you know how to do this problem when you get there. All right, I hope this helped.
The Teaching Center, UF's Learning Resource Center.